Stories and Documentary Network.
Across the world, the names of great builders echo through history. The pyramids of Egypt, the aqueducts of Rome, the temples of Greece. Their marvels are studied, photographed, and celebrated. Yet, hidden in plain sight, lies another story. One of engineers who worked in silence, whose genius was as vast as it was precise, but whose names rarely reach our textbooks. In the heart of the Indian subcontinent, long before cranes or modern machinery existed, civilizations rose that could bend stone and water to their will. They carved subterranean stepwells that descended like inverted temples into the earth, harvesting and preserving water with an elegance that modern engineers still marvel at. They erected towering temples of granite, perfectly balanced, surviving earthquakes and centuries of neglect. This was not just architecture. It was a philosophy, a way of understanding the world. Nature was not an obstacle to overcome, but a partner to collaborate with. Every stone, every channel of water, every carefully measured axis reflected a deep understanding of mathematics, physics, and cosmology, all centuries ahead of its time. Yet despite these extraordinary feats, these silent geniuses remain largely forgotten in global narratives. Their work endured while their names faded, their brilliance hidden beneath the dust of history. Tonight, we embark on a journey to uncover these unseen architects. We will explore their innovations, their philosophies, and the remarkable structures that continue to inspire awe, standing as timeless testaments to a civilization that engineered eternity. Long before the rise of empires that would dominate vast territories, before kings carved their names into stone, engineering in the Indian subcontinent had already reached heights that would astonish the modern world. This story begins along the banks of mighty rivers, where the first seeds of urban civilization took root. The Indus Valley civilization, flourishing around 2600 BCE in what is now northwest India and Pakistan. Cities like Mohenjo-daro and Harappa were marvels of planning and foresight. At first glance, they might seem ordinary, clusters of brick houses, streets winding in geometric patterns. Yet a closer look reveals astonishing sophistication. Streets ran in precise grids, wider lanes accommodating the flow of people and trade, narrower alleys for households, demonstrating a conscious understanding of urban traffic management. Homes were constructed with standardized baked bricks, uniform in size and quality, ensuring both durability and aesthetic harmony. Beneath the streets, elaborate drainage systems carried wastewater away from the city, employing gradients calculated with precision to maintain a steady flow. This was not haphazard construction. It was a calculated marriage of science and necessity, a testament to an advanced understanding of hydraulics, urban sanitation, and environmental adaptation. The geography of the region shaped these early engineers' vision. Seasonal monsoon floods could devastate unprepared settlements, while the shifting course of rivers demanded foresight in city placement. The Indus engineers responded with ingenuity. Elevated platforms protected homes, reservoirs captured water for dry seasons, and riverbanks were reinforced to control erosion. Nature was not an adversary to overcome. It was a partner, guiding design decisions with lessons that every stone and canal would eventually reflect. Engineering in these early cities was deeply intertwined with culture. The Indus people understood that functionality and beauty were inseparable. Public baths, like the Great Bath of Mohenjo-daro, reveal a sophisticated grasp of water management and social organization. They were carefully waterproofed with baked bricks and bitumen, channels directed water in and out efficiently, and steps allowed safe access, a public space both practical and ceremonial, blurring the line between utility and ritual. Water was not merely a resource, it was a living sacred element, central to both daily life and spiritual practice. Trade and economy reinforced this technological sophistication. The Indus Valley stretched across hundreds of kilometers, connecting settlements with rivers, roads, and possibly even sea routes. Craftsmen and traders needed storage systems, marketplaces, and communication networks, all of which required planning and construction on a massive scale. We see the earliest hints of standardized weights and measures, suggesting coordination across vast distances, allowing goods and ideas to flow with efficiency that would inspire later civilizations. But engineering was never just practical. It was philosophical. The Indus engineers understood proportion, symmetry, and orientation. Buildings were often aligned along cardinal directions, hinting at an early awareness of astronomy and solar patterns. The layout of cities may have reflected concepts of harmony, balance, and cosmic order, ideas that would evolve into the sacred geometry and architectural texts known in later Indian history as Vastu Shastra. Here, science and spirituality were inseparable. Every brick was a calculation, every street a rhythm of life. As the Indus civilization waned, the knowledge it cultivated did not vanish. It transformed, migrating through time and space, influencing later cultures along the subcontinent. Rivers that once nurtured early settlements became the lifeblood of Vedic kingdoms, whose priests, astronomers, and scholars codified geometry, mathematics, and urban planning principles that would shape cities for centuries. By the time the first grand stone temples arose millennia later, India's engineers were standing on a foundation laid by their Indus ancestors. A belief that structure could endure, that water could be harnessed elegantly, and that design was a dialogue with the earth itself. Even in the rugged landscapes beyond the fertile river valleys, these principles guided settlements. Hills and mountains were not obstacles, but canvases. Terraced agriculture demonstrated understanding of soil stability and water flow. Caves and rock-cut sanctuaries, later refined in the Ajanta and Ellora complexes, began as humble experiments in integrating human structures with natural formations. Early engineers recognized the power of geography, and instead of reshaping it forcibly, they adapted their designs to it, a philosophy that would echo through centuries of Indian architecture. The story of Indian engineering begins, therefore, not with stone towers or massive temples, but with rivers, bricks, and the flow of water. It begins with a civilization that observed, measured, and harmonized with the natural world. The Indus Valley people laid the foundations for a tradition where human ingenuity and the sacred landscape became inseparable. Centuries later, their descendants would scale these lessons to monumental heights, carving temples and stepwells that defied gravity and time, all while honoring the principles first discovered along these early riverbanks. This is where our journey into India's hidden engineering marvels begins. In the grids and drains of cities forgotten by history. In the wisdom of early engineers who saw not obstacles but possibilities. It is here, in these ancient landscapes, that the silent conversation between humanity and nature first took form, setting the stage for feats that would leave the world in awe. In ancient India, engineering was never an isolated craft. It was inseparable from the rhythms of life, the cycles of the cosmos, and the very beliefs that shaped society. To build was to honor the universe, to harmonize human existence with nature's invisible laws. Every stone, every canal, every carefully measured axis carried meaning beyond its practical function. Daily life revolved around order, ritual, and utility. Communities were organized with remarkable foresight. Streets and neighborhoods reflected social and economic hierarchies, yet every settlement incorporated public spaces, water access, and communal facilities. Markets thrived, carrying not just goods, but knowledge and innovation. Artisans, traders, and farmers coexisted in a delicate balance, each contributing to a system designed to endure. Economy and culture were intertwined. The success of a community depended as much on social cohesion as on trade or craft. Religion and philosophy infused every aspect of life. Temples were not merely places of worship, they were cosmic diagrams. Built along precise cardinal axes aligned with solar and lunar cycles, they embodied the principles of Vastu Shastra, a science of architecture that balanced energy, harmony, and proportion. Sacred geometry dictated dimensions, ratios, and even the placement of sculptures, reflecting a belief that the universe itself was structured according to mathematical perfection. In this way, human construction mirrored the cosmic order, creating spaces that resonated with both mind and spirit. Water, too, held a central role in both daily life and devotion. Stepwells, reservoirs, and tanks were functional yet profoundly symbolic. They supplied life, controlled floods, and cooled the air, but they also served as spaces for ritual purification and communal gathering. In every structure, the practical and spiritual were intertwined. To manage water efficiently was to respect the gods, to live in harmony with the forces that sustained life. Art and craftsmanship flourished within this cultural framework. Sculptors carved intricate motifs of flora, fauna, and myth, while architects calculated load-bearing stones with an almost mystical precision. Painting, metalwork, and textiles reflected patterns of cosmic significance, echoing symmetry and proportions seen in temples and urban layouts. Knowledge was not divided into separate disciplines. Mathematics, astronomy, philosophy, and artistry coexisted, each informing the other. Education and guilds ensured the continuity of this wisdom. Young apprentices learned not only technical skills, but ethical principles, rituals, and the philosophy behind each design. Knowledge was considered sacred, passed carefully through generations, often orally or through symbolic diagrams rather than written manuals alone. Innovation was encouraged within this framework of respect for tradition, creating a culture that celebrated both mastery and humility. Trade connected Indian cities to distant lands, spreading ideas as well as goods. Merchants carried spices, metals, textiles, and knowledge to Persia, Mesopotamia, and beyond, embedding India's ingenuity into the global narrative of civilization. Yet even in commerce, principles of balance, fairness, and reciprocity governed exchanges, reflecting the broader societal emphasis on harmony and sustainability. In essence, ancient Indian society was a civilization built for eternity. It understood that human life, nature, and the cosmos were interconnected, and that structures should honor all three. Houses, temples, cities, and canals were designed to endure both physically and spiritually. This fusion of utility, philosophy, and beauty allowed ancient Indian engineers to create systems that were efficient, elegant, and profoundly meaningful. It is within this cultural context that the true genius of India's unseen architects emerges. Their monuments were not mere feats of construction. They were embodiments of a worldview, bridges between the earthly and the divine, and testimonies to a civilization that saw eternity not as abstract, but as something to be built, measured, and lived in daily. To walk through an ancient city or stepwell is to step into this philosophy, to witness a society that understood the profound power of design, not for wealth, nor for conquest, but for the enduring harmony of life itself. Here, culture and engineering were one, and every stone tells a story of a civilization that built not only for its people, but for the ages. The genius of ancient Indian civilization is perhaps most striking in its achievements, the feats of engineering that defy both gravity and expectation, the innovations that turned stone and water into instruments of human ingenuity. These were not isolated experiments. They were part of a continuous tradition, a philosophy where every structure was a dialogue between human skill and nature's challenges. Take the stepwells, for example. In the sun-scorched plains of Western India, water is life, and life demanded extraordinary solutions. Stepwells are architectural marvels, plunging deep into the earth, sometimes descending 7 stories below the surface. At first glance, they appear to be nothing more than monumental staircases, but their function is far more sophisticated. Stepwells like Rani Ki Vav in Patan were engineered to harvest monsoon rain, regulate groundwater, and provide cool spaces in extreme heat. Hundreds of steps, terraces, and pavilions form a complex lattice, all precisely calculated to ensure structural integrity as they descend into the earth. Water flows through carefully carved channels directed to reservoirs at the base, replenishing the aquifers and sustaining entire communities for months without rain. But stepwells were not merely utilitarian. They were also temples in their own right. Each wall, pillar, and platform was intricately carved with iconography, depictions of deities, flora, fauna, and cosmological motifs. The descent into the well became a spiritual journey, a reflection of life's passage and the eternal cycle of nature. Function and ritual, science and art, merged seamlessly in these subterranean masterpieces. Above ground, Indian engineers achieved equally remarkable feats in temple construction. The Brihadiswarar temple in Thanjavur, built under the Chola dynasty in the 11th century, rises over 60 meters, crowned with a single granite capstone weighing approximately 80 tons. Modern engineers struggle to comprehend how such a stone could be quarried, transported, and lifted without cranes or modern machinery. Yet the builders succeeded, likely using a series of inclined planes and human ingenuity honed over generations. The precision of their calculations ensured that the weight of the tower distributed evenly, preserving stability for over 1,000 years. Temples like these were more than religious spaces. They were scientific instruments. Their alignments often corresponded with celestial events, their proportions based on ratios derived from mathematical treatises. Sound, light, and space were carefully considered, creating acoustics and illumination that enhanced rituals and the spiritual experience. Even the act of walking through the temple, from entrance to sanctum, was a carefully choreographed journey, a physical manifestation of sacred cosmology. Metallurgy, too, was an area where ancient Indian innovation defied time. The iron pillar of Delhi, standing over 7 meters tall and weighing more than 6 tons, has resisted corrosion for over 16 centuries. This rust-resistant marvel demonstrates a sophisticated understanding of iron production, alloying, and environmental interaction. Scientists today marvel at the composition, noting the high phosphorus content and unique forging techniques that allowed the pillar to withstand monsoon rains, acid, and the passage of time. It is a testament not only to skill, but to the empirical observation of materials and environment, knowledge gained through experience, experimentation, and careful record-keeping. Urban planning was no less impressive. The cities of the Indus Valley and later settlements across India integrated drainage, water storage, and waste management in ways that even modern urban centers struggle to replicate. Streets were not just pathways, they were arteries of sanitation. Drainage systems were sloped, covered, and connected to public baths, reservoirs, and natural waterways. Rainwater harvesting was standard practice, with tanks and ponds positioned to maximize collection and minimize flood risk. Cities were designed to survive, not merely to impress. They were resilient ecosystems, balancing human needs with environmental realities. Engineering extended to transportation and infrastructure. Stone bridges, causeways, and canals facilitated trade and communication across vast regions. Roads were often lined with milestones, reflecting knowledge of distance measurement, geometry, and surveying. Even irrigation systems reveal mastery over terrain, as channels were designed to control flow, prevent soil erosion, and distribute water equitably among fields. These achievements were not random. They reflect a holistic vision where every innovation served multiple purposes, blending utility, aesthetics, and environmental harmony. The innovation was not limited to large-scale public works. Domestic architecture also reflects remarkable sophistication. Step terraces on hill slopes, wind cooling systems in homes, and reflective water tanks were employed to regulate temperature and conserve water. Materials were chosen for durability, thermal properties, and local availability. Roofs, walls, and floors were often layered with stone, brick, and plaster in combinations that optimized insulation, strength, and longevity. Even small details, drainage spouts, threshold stones, and window designs were considered in relation to climate, water flow, and human ergonomics. What stands out in all these achievements is a continuity of knowledge. From the Indus Valley to the Chola Empire, from subterranean wells to monumental temples, the principles of engineering, mathematics, and environmental science remain deeply embedded in society. Builders learned from observation, experimentation, and oral transmission, refining techniques over generations. This cumulative wisdom created structures that were not only functional but poetic, reflecting both scientific acumen and cultural philosophy. Even in the face of immense natural challenges, monsoons, earthquakes, and floods, these structures endured. They were designed to adapt, to survive, and to serve communities for centuries. The combination of material mastery, mathematical precision, and environmental understanding enabled ancient Indian engineers to create solutions that were as practical as they were visionary. Perhaps the most remarkable aspect of these achievements is their integration into daily life. Engineering was not a distant, abstract pursuit. It was lived, experienced, and honored. Stepwells became social hubs. Temple tanks provided water for ritual and community use. Urban streets doubled as drainage channels. Metallurgical innovations created both sacred icons and practical tools. Every advancement served multiple layers of human need: practical, spiritual, and aesthetic, embodying a philosophy of holistic design that is rare even today. In many ways, these achievements remain unparalleled. Modern engineers, architects, and urban planners still study stepwells, temples, and drainage systems for their ingenuity, efficiency, and elegance. Yet, despite the global admiration for other ancient civilizations, the engineers of India remain largely unsung. Their work stands silently across centuries, whispering lessons of balance, foresight, and resilience. To walk through a stepwell, to stand beneath the shadow of a massive temple tower, or to trace the flow of an ancient drainage system is to witness a civilization that understood not only the mechanics of construction, but the philosophy of permanence. These were structures designed to endure, to serve, and to inspire. They were the physical embodiment of a civilization that refused to separate science from art, utility from devotion, and the human from the natural world. The unseen architects of India defied gravity, mastered water, and shaped stone into enduring monuments. Their legacy is not only in the structures they left behind, but in the principles they embodied: innovation, harmony, and the belief that human ingenuity could meet the challenges of both nature and time. History often remembers kings, conquerors, and empires, yet the true architects of civilization frequently remain in the shadows. In ancient India, it was the master builders, the anonymous engineers, and the guilds of craftsmen who transformed landscapes into enduring marvels. Their work shaped cities, temples, and water systems that continue to astonish the world, yet their names rarely survive in written records. These visionaries were more than skilled artisans. They were philosophers, scientists, and mathematicians. From the early Indus Valley planners who designed precise drainage systems and standardized bricks, to the architects of towering Chola temples, each generation built on the knowledge of its predecessors. Techniques were passed orally, encoded in chants, proportional diagrams, and apprenticeship rituals. Knowledge was sacred, carefully guarded, and methodically transmitted from master to student. Dynasties played a crucial role in fostering this brilliance. Rulers such as Raja Chola I did not merely commission monumental temples. They cultivated entire ecosystems of talent. Architects, stonemasons, sculptors, astronomers, and hydraulic engineers worked in concert, blending practical skills with spiritual insight. Under such patronage, innovation thrived. Stone towers were lifted, massive capstones were balanced, and stepwells carved deep into the earth, all achieved without modern tools, relying on geometry, physics, and collective expertise honed over centuries. Yet many of the most remarkable figures were anonymous. Guilds, known as shrenis, were the custodians of craft knowledge. Each guild specialized in a domain: stone carving, metalwork, water engineering, or urban planning, and operated like a university of practical science. Within their ranks, young apprentices learned not only the techniques of their trade, but the philosophy behind every measurement, angle, and curve. Every temple pillar, every stepwell staircase, every iron pillar reflects the intelligence, discipline, and creativity of countless hands and minds working together in harmony. Some visionary builders became legends, their names entwined with the monuments they left behind. Vishwakarma, the divine architect of Hindu tradition, symbolizes the ideal of human ingenuity infused with cosmic understanding. While mythic, Vishwakarma represents the collective wisdom of generations who saw engineering not just as construction, but as creation aligned with universal principles. In practice, countless master builders fulfilled this vision, translating philosophy into stone, metal, and water. The collaboration between rulers and engineers was symbiotic. Kings provided resources and protection, but innovation emerged from the architect's understanding of mathematics, astronomy, and environmental science. Temples were not just expressions of devotion, they were experiments in acoustics, light, and load-bearing. Stepwells balanced structural integrity with aesthetic beauty. Cities flowed with precision because engineers anticipated rainfall, flood, and human activity centuries in advance. These achievements required visionaries who could think beyond the immediate and design for eternity. What is remarkable is the holistic approach these figures embraced. They did not isolate art from function or science from spirituality. An iron pillar that resists corrosion is simultaneously a religious icon and a metallurgical marvel. A stepwell cools the surrounding air, conserves water, and elevates ritual into a communal experience. Master builders understood that the success of a structure depended on balance between nature and design, between the divine and the human, between practicality and inspiration. Even today, their influence endures. Modern architects and engineers study ancient Indian designs to understand passive cooling, rainwater management, and structural longevity. Their insights remind us that innovation is rarely solitary. It is a cumulative effort, a dialogue across generations. Each monumental stone, each channel, each precisely measured axis is a signature of minds attuned to both the earthly and the eternal. In celebrating these unseen architects, we recognize a profound truth. Civilizations are shaped not only by kings and empires, but by those who quietly labor to turn vision into reality. The Cholas, the Mauryas, and the Indus engineers all remind us that mastery often lies behind anonymity, that knowledge survives best when shared, and that the most enduring monuments are born of both human skill and imagination. Even the greatest engineering marvels are not immune to the relentless forces of history. In ancient India, the structures that symbolized ingenuity, devotion, and resilience faced challenges that tested their very survival. Wars, invasions, natural disasters, and the passage of time threatened to undo centuries of careful planning. Yet these creations endured, bearing silent witness to the resilience of human vision. From the Indus Valley to the grand Chola temples, Indian cities and monuments were periodically caught in the crossfire of invading armies. Empires rose and fell, leaving in their wake destruction, pillaging, and disruption. Temples were plundered, stepwells filled with debris, and cities abandoned as populations fled conflict. Yet even in ruin, the precision of engineering remained. The alignment of streets, the integrity of water channels, and the balance of massive stones often survived, allowing later generations to restore or reinterpret them. Nature itself posed a formidable adversary. Seasonal monsoons, unpredictable river flooding, and droughts required constant adaptation. Reservoirs overflowed, irrigation canals silted, and entire settlements were forced to relocate. The very landscapes that nurtured life also demanded vigilance, foresight, and maintenance. Engineers designed with these pressures in mind, yet centuries of neglect could render even the most sophisticated systems vulnerable. The monsoon, so central to agriculture and survival, became both a blessing and a challenge, requiring innovations that balanced abundance with control. Time, the quietest adversary of all, left its mark through erosion, decay, and gradual deterioration. Granite towers weathered centuries of rain and wind. Brick cities crumbled under the weight of neglect. Stepwells, once cool and sparkling, slowly filled with sand and debris as societies changed and water systems fell into disuse. Even metallurgical marvels like the rust-resistant iron pillars endured corrosion in small measures, a reminder that no material, however advanced, is entirely invulnerable. Colonial interference introduced yet another form of disruption. When European powers arrived, indigenous knowledge systems were often dismissed as primitive or mystical. Construction techniques, hydrological expertise, and urban planning methods that had evolved over millennia were undervalued or ignored. Temples and stepwells were sometimes repurposed or abandoned, cutting the continuity of engineering traditions. Knowledge that had been carefully passed through guilds and apprenticeships faced a threat not from war or nature, but from erasure of cultural respect and institutional memory. Yet despite these overwhelming challenges, the ingenuity of India's engineers endured. Many stepwells remained functional, rediscovered and restored centuries later. Temples continued to stand, their massive stones unshaken by earthquakes or invasions. Cities, even in partial ruin, preserved the logic of their original planning. What survives is a testament to foresight and resilience. A reminder that true engineering is not only about building, but about anticipating adversity, designing for longevity, and harmonizing with the forces of nature. Conflict, climate, and neglect tested these civilizations, yet their monuments resisted oblivion. Their survival is a story of both human brilliance and endurance, a dialogue between ingenuity and the relentless pressures of the world. And it is precisely in these challenges, and the triumph over them, that the silent genius of India's unseen architects becomes most evident. Civilizations, no matter how advanced, are rarely static. In India, the golden thread of engineering and architectural mastery faced profound transformations over centuries. As dynasties rose and fell, the patronage that had once fueled monumental construction shifted. Kings who had once commissioned grand temples and stepwells gave way to new rulers with different priorities, leaving some projects unfinished, others neglected. Knowledge that had been celebrated slowly receded from public life, preserved only in the quiet teachings of guilds and oral traditions. Colonial encounters brought yet another upheaval. European powers often dismissed India's sophisticated engineering as primitive or mystical, failing to recognize the scientific principles embedded in stone, water, and metal. Urban planning, hydrology, and temple architecture were reinterpreted through the lens of foreign assumptions, and many practical innovations fell into obscurity. Stepwells, once bustling with community life, were abandoned. Reservoirs and aqueducts were neglected, sometimes dismantled, and the meticulous practices of Indus and medieval engineers faded from mainstream awareness. Yet, the knowledge was not lost, only buried. Guilds continued to pass skills quietly from master to apprentice. Artisans preserved techniques of carving, metallurgy, and construction within localized communities. Ancient texts and proportional guidelines, written in Sanskrit or regional scripts, remained in temples, monasteries, and libraries, safeguarding principles that would later inspire revival and study. Even as large-scale construction slowed, these traditions endured, maintaining continuity with centuries of accumulated wisdom. This period of transformation also allowed for reinterpretation. Engineers adapted older techniques to new contexts, experimenting with regional materials, evolving water management methods, and incorporating astronomical alignments in novel ways. Temples and civic structures built in later centuries reflected both continuity and innovation, blending ancient principles with the needs of new patrons and changing societies. In many ways, this was not a decline but a metamorphosis, a preservation of ingenuity under the pressures of political and cultural change. The story of decline in India is therefore not one of disappearance but of resilience. Knowledge may have retreated from public prominence, but it survived in the hands of those who understood its value. Like seeds lying dormant in winter soil, the wisdom of India's unseen architects waited for circumstances to rekindle it, ensuring that the principles of harmony, precision, and sustainability would endure beyond dynasties, invasions, and centuries of neglect. Despite the remarkable structures they left behind, many architects have slipped into obscurity, their names lost to the passage of time. This fading from history often results from shifting cultural priorities, incomplete records, or the overshadowing fame of their contemporaries. Yet their creations endure, silently shaping the landscapes and communities we inhabit. The legacy of these forgotten visionaries continues to inspire, reminding us that true innovation can transcend recognition. By acknowledging their contributions, we honor the enduring spirit of creativity and ensure their stories remain part of our shared heritage. Centuries may separate us from the builders of India's ancient cities, yet their wisdom continues to resonate in a world facing new challenges. The stepwells, reservoirs, and carefully planned urban grids of antiquity were not just solutions for survival, they were models of sustainability, foresight, and harmony with nature. Today, as modern cities grapple with water scarcity, climate change, and rapid urbanization, these ancient principles offer lessons as urgent as they are inspiring. Stepwells, once the lifeblood of communities, exemplify a philosophy of resource management that is strikingly relevant. In regions where water is scarce, these subterranean marvels collected rain, replenished aquifers, and provided access throughout the year. Modern engineers are revisiting these techniques, studying the geometry, gradients, and storage strategies that allowed water to be conserved efficiently and naturally. The logic is elegant. Rather than forcing nature to conform, work with its cycles, capture its abundance, and distribute it sustainably. Urban planning, too, holds enduring insights. The grids of Mohenjo-Daro, the alignment of temples and streets in later cities, and the integration of drainage and sanitation reflect a holistic understanding of human settlements. Modern cities struggle with traffic, sewage, and flooding precisely because this integrated vision has been lost. By examining ancient layouts, contemporary architects and planners are rediscovering the power of design that balances function, environment, and human experience, creating spaces that are resilient, livable, and in rhythm with natural forces. The principles of temple engineering and material science remain equally instructive. Granite towers, iron pillars, and terraced structures demonstrate how local materials, precise calculations, and an awareness of environmental forces can create structures of remarkable longevity. Today's architects study these methods to design buildings that endure, reduce waste, and maintain structural integrity with minimal intervention. The ancient approach was not merely to build for the moment, but to craft for centuries. A mindset that resonates deeply in an era increasingly aware of sustainability and ecological responsibility. Even cultural and philosophical insights endure. Ancient engineers understood that design was not only technical, but ethical. Structures were intended to serve communities, enhance social cohesion, and reflect harmony with the cosmos. Modern sustainable design echoes these same principles. Architecture is most successful when it serves both people and environment, when it respects local conditions, and when it anticipates future generations. This legacy has inspired a global appreciation of India's engineering marvels. Stepwells, temples, and urban grids are studied by historians, architects, and engineers worldwide, not merely as curiosities of the past, but as blueprints for innovation. Conservation efforts, adaptive reuse, and scholarly research seek to recover both the physical structures and the underlying principles, ensuring that the ingenuity of these unseen architects continues to shape the present. Ultimately, the enduring relevance of ancient Indian engineering is a testament to human ingenuity that transcends time. The solutions devised thousands of years ago, solutions to water scarcity, climate adaptation, and urban complexity, remind us that sustainable living is not a modern invention, but a rediscovery of the wisdom embedded in our shared past. The silent genius of these architects lives on, guiding us to build not only for today, but for centuries yet to come, proving that the greatest innovations are those that endure, inspire, and harmonize with the world around us. As the sun sets over ancient stepwells and temple towers, their shadows stretch long across the land, whispering stories of minds that once shaped the world with stone, water, and vision. These silent architects did not seek fame, they sought harmony. They understood the language of the earth, the flow of rivers, the rhythm of seasons, and the patterns of the cosmos. Every structure they left behind is a conversation, a dialogue between human ingenuity and the natural world, spoken in granite, brick, and flowing water. We walk through their creations today, often unaware of the sophistication that lies in every detail. A stepwell is no longer just a well. It is a marvel of hydraulics, a cooling sanctuary, a space where community and ritual converge. A temple tower is no longer merely a monument. It is a triumph of mathematics, physics, and celestial observation, crafted without cranes, machines, or modern tools. These works remind us that engineering is not merely about construction, but about understanding, anticipating, and collaborating with the forces around us. Yet the world has often overlooked these achievements, allowing the narrative of innovation to be dominated by other civilizations. The genius of India's unseen architects has been relegated to the shadows, their knowledge buried under centuries of neglect, colonization, and shifting priorities. But perhaps it is in this very silence that their message grows louder. Ingenuity is timeless, and true mastery is measured not by recognition, but by endurance. As we reflect on these marvels, we are called to rethink history, to expand our understanding of human achievement beyond the familiar monuments and textbooks. The legacy of these builders challenges us to honor ingenuity wherever it arose, to recognize the intelligence embedded in ancient civilizations, and to learn from principles that remain profoundly relevant today. The stepwells still capture water. The temples still withstand time. The streets still reflect planning centuries ahead of their age. And in these enduring works, the architects continue to speak, urging us to listen, to marvel, and to remember that human creativity, when guided by vision and purpose, can truly defy time itself.